Hi, hello, namaskara. Welcome back to Diksha Karnataka with yet another mock test paper analysis and discussion, solution discussion. We are going to do as usual the part one, first 30 questions from question number 121 to 150. So for all those people who are looking forward to this particular discussion, I hope you have attended the test. If you have not, so quickly join our WhatsApp channel. The link is given right in the description box. Alright, so join our WhatsApp channel for all the updates regarding the Abhyas KCET mock test, or even if it is the crash course, or any detail can be followed up in the WhatsApp channel. Also for those people who are looking forward to kind of get away from the social media distraction all, we have a dedicated portal for you. The link is again given in the description box itself, so you can go register yourself. You can get the PDF of the paper directly to your mail ID, and you can download and you can kind of attempt at your own comfort level. All right, so we are going to discuss all the questions, first 30 questions detail. So let's start from the first question, shall we? Okay, the first question is like this. The mean radius of Earth is r, its angular speed on its own axis is omega, and the acceleration due to gravity at Earth's surface is g. What will be the radius of orbit of the satellite? Okay, so we want the radius of the orbit of the satellite with respect to r, g and omega. All right, so let's start with something that we know. Okay, so let's start from the time period aspect. So time period of a revolution, as we know, is given as t is equal to 2 pi r, the radius of the orbit, divided by the orbital velocity. So which is given by 2 pi r whole divided by square root gr square by r. Simplifying it further, you will get 2 pi r to the power 3 by 2 whole root gr square. Alright, let it as it is. So this is the first kind of iteration of the time period. The other time period formula which you all know is that time period is equal to 2 pi by omega. Alright, so now what we have done is that we have gotten all the components which are given in our question in the options that we need to deduce, okay, with respect to the orbital radius r. So now equate both the time period, so time period formula this and this, when we equate, you get 2 pi r to the power 3 by 2 whole divided by root gr square is equal to 2 pi by omega. So 2 pi cancels, r to the power 3 by 2 is equal to root so root gr square whole divided by omega. Square on both the sides, take the cube root, so r is equal to gr square by omega square whole power 1 by 3, which is absolutely option B. Alright, sorry, not option B, option A. Yes, r square g divided by omega square whole power 1 by 3. Alright, so what we have done is that we have taken the known value time period and we have equated both of its iterations, because we ultimately what we want is the orbital radius, and equating both, cancel out in similar terms, ultimately we get the orbital radius in terms of g, r and omega, that is option A. The first question, yes, it is not a straightforward question, slightly difficult, so it's not easy, not a very difficult question as well, somewhere in the mediocre level. All right, so I hope a few people at least you would have gotten somewhere. So it's, if you would have, it's really good job, because not a very straightforward question, right? Yes, let's look at the next question. If two equal and opposite deforming forces applied parallel to the cross section area like this, so one force like this, one force like this, so there is a strain over here. Okay, so there is a relative displacement between the opposite faces. So the top face is ahead of the bottom face. There is a relative displacement. What is this strain called? This strain is absolutely called shearing strain. Okay, it is neither volume longitudinal nor is it Poisson's ratio. It is exactly shearing strain, the relative displacement between both the sides when there is equal and opposite forces. Correct. So that is option C. Very simple question. Look at the question number 123. The center of mass of a triangle system shown in the figure. Okay, so there is a figure over here. Let me see. Okay, the figure. Okay, let me give you the figure. So it's like this. Okay, triangle figure. In the if three equal masses are placed with three vertices, so we have x, y, okay, and you have masses, one at the origin, one at a distance b from the origin in the x-axis, and the other at a distance h from the origin in the y-axis. So this is a triangular system that we are talking about, triangular system. All right. So three masses, let me just denote them. Each mass, this is the, they are all identical. Okay, masses are all identical. Okay, same mass m. Now what is the center of mass? Now let us just assign position for each masses. The position at the origin is absolutely 0, 0. Now in the x-axis it is at the distance b. So this position is b comma 0, and in the y-axis 0 comma h. Alright. Now let's find the x component and the y component of the center of mass separately. First let's find the x component. So x component is given as m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Now what is given over here, they're all identical masses. That means m1 equals m2 equals m3 m. So substituting all the values, and we have x1 is 0, x2 is b, x3 is also 0. So only this particular mass will sustain, m into b divided by 3m. So it is x is equal to b by 3. Alright. The same thing can be applied with y. So look at this. Okay. Same thing can be applied for y as well. So we have the same formula, m1 y1 plus m2 y2 plus m3 y3 whole divided by total mass. Now I didn't write m1 plus m2 plus m3. We all know it is 3m. Alright. Alright, it is 3m. So now again substitute the corresponding y1, y2 values. So y1 over here is 0, y2 over here is 0, y3 is h. So we will have one component, that is 3, m into h, okay, m into h divided by 3m. So we will have mm cancel, h by 3. So the y component is h by 3. So x component is b by 3, y component is h by 3. So the correct answer is yes, option C. Alright, so option C is the most matching answer. It's actually a very simple question. The center of mass for a multiple body system. First of all, they have given all the points very correctly, very clearly. So you don't have to try to calculate the points and all the distances. So you can easily crack that, and then you can find the using the simple formula. Okay, very easy question. Let's look at the next question. If the terminal speed of a sphere of gold density is given is 0.2 meter per second in a viscous liquid, find the terminal speed of silver density is given of the same size. Now all of you know the formula. I hope it's a very big formula for terminal velocity, but assuming everything is constant, the only thing varying over here is the density. So how is terminal velocity related to density? That is the actual cracker. So terminal velocity is actually proportional to the difference in the density of the solid and density of the liquid. Okay. Terminal velocity of solid as in what is falling into the liquid, and the liquid density. Okay. So if you want to take a ratio, so we can take V1 by V2 is equal to difference. Okay. For example, gold. So let's assume V1 is gold. Okay. V1 is velocity of gold, let's assume, and V2 is the velocity of silver. Okay, so now let's substitute. So V1 density difference in gold and the liquid. So that is 19.5 minus 1.5 whole divided by density difference in silver, 10.5 minus 1.5. So we have here exactly V1, which is already given 0.2. 0.2 divided by V2 is equal to 19.5 minus 1.18 divided by 10.5 minus 1.5 is 9. So this is 2. So again cross multiply, V2 is equal to 0.2 divided by 2. This 2 will come down, right? This 2 will come down. So this is absolutely 0.1 meter per second. So the correct answer is option C, 0.1 meter per second. Alright. So this is the correct answer. Once again, only thing that you have to keep in mind is what is the relation. Okay, what is given and what you have to relate. The formula is pretty big, you know, 2r square d1 minus d2 by 6 eta and all that. Okay, but here since everything is constant, if there is no multiple liquids over here, the same liquid we are using, so you just have to see that the velocity is proportional to density, change in density, and then you can take the ratio correspondingly. Okay, once again very simple if you know this relation. If you know the relation, it's a very simple business. All right, fine. Let us look at the next question. A body initial at 80 degrees Celsius cools to 64 in 5 minutes, then to 52 in 10 minutes. Then the temperature body after 15 minutes will be. Yes. So this is based on Newton's law of cooling, and this is a pretty lengthy solution. Okay, lengthy and slightly complicated. You have to be careful at each step. So I'll give you a brief overview of the solution. And this question, Newton's law of cooling, I'm not sure how far it will come in the upcoming edition of the KCET. So let's just have anyway a brief discussion. So we have to see the stages, how the temperature is decreasing. First, for any stage, okay, if temperature is decreasing from theta 1 to theta 2, okay, and theta naught is the surroundings temperature is theta naught. According to Newton's law of cooling, theta 1 minus theta 2 divided by the time taken is equal to theta 1 plus theta 2 by 2 average minus the surroundings temperature into a constant K. Okay, so this is Newton's law of cooling, what Newton's law of cooling proposes. Okay, that means the rate of change, rate of fall in temperature is proportional to the fall in temperature, how much the temperature has fallen. So that itself is the factor at which the rate depends upon. So lesser the fall in temperature, lesser will be the rate. Okay, so now at each occasion, so first it is changing from 80 to 64. At that point, what will be the equation? 80 minus 64 divided by in 5, okay, degrees Celsius in 5 minutes. Okay, so divided by 5 is equal to 80 plus 64 by 2, average of both of them, minus theta naught. Okay, so let this be one equation. Okay, let this be equation 1. Now we can have the next, that is 64 degrees Celsius to 52 degrees Celsius in 10 minutes. So we will have again the equation 64 minus 52 divided by 10 is equal to 62 plus 54 divided by 2 minus theta naught. Now theta naught is unknown. Okay, theta naught is unknown. So what I suggest is divide both the equations. Okay, divide both the equations, you will get theta naught. Divide 1 and 2 to get the theta naught. Okay. Now ultimately what you have to do is, so find the final temperature. Okay, for final temperature T, where 52, from 52 it goes to some temperature. Okay, 52 degrees Celsius to T. So we will have 52 minus T divided by 15 minutes and the 52 plus T by 2 minus theta naught. So just substitute theta naught here and solve for T. Okay, substitute theta naught and solve for T. This is, yes, a very lengthy question and very tricky also. You cannot miss at even a single step. The entire answer will crash. So you have to take one by one at each step. What is the variation? First, determine theta naught, divide both of them, solve the equation, find theta naught, okay, and then substitute in the ultimate equation, the final equation, and you will get T as 42.7. Okay, ultimately you will get T as 42.7. So the calculations can be carried out by all of you. If at all there is any contradiction in the final answer, you are getting, sir, not getting this answer, or there is some, please let me know in the comment section. Okay, so let's have a productive discussion in the comment section. So all of you, please let me know. Just calculate it yourself, and I surely believe that most of you will get the correct answer. All right. Okay, so this was a very difficult question. All right, let's look at the next question. So this is question number 125. The next question is question number 126. Okay, yes, 4 mole of hydrogen, 2 moles of helium and 1 mole of water vapor form an ideal gas. What is the molar specific heat capacity at a constant pressure of the mixture? So they are talking about the partial pressure. Okay, so we are talking about the partial pressure mixture of gases. So what will happen to the mixture of gas, CV in mixture? First of all, you need to know CV of each of them. So for hydrogen, we have a diatomic molecule. So CV here is actually 5 by 2. All right. And then we have helium. Okay. So helium is monoatomic. So that is 3 by 2. Okay. Monoatomic gas, it's 3 by 2. And ultimately you have water vapor. Water vapor is a special case. So its CV is actually 3R. So which we have already studied. Okay. Water vapor, or for water, the specific heat, molar specific heat capacity is 3R. Okay. Because of course it's a non-linear structure and it's a triatomic molecule, all that, fine. So these are the respective CV, that is the molar specific heat. Now let's talk about the mixture. Okay, now coming to the mixture, very important. So for any mixture, generally, okay, CV of the mixture is given as the sum of product of the mole and this thing, CV, okay, plus N2 CV2. Okay, so each gas its own mole multiplied with its molar specific heat capacity and take a total. Okay, and this ultimately whole divided by the total number of moles, N1 plus N2 plus N3 plus goes on. So this is how you get the CV of the mixture. Okay, the mixture is multiple of moles and molar specific heat capacity, each gas added divided by total number of moles. So how do you get this? First of all, for hydrogen we have 4 into 5 by 2 plus we have next 2 moles of helium, 2 into 3 by 2 plus 1 water vapor, 1 into 3 whole divided by 4 plus 3 plus 1. Okay, 4 plus 2 plus 1. Sorry, it's 2, not 3. Yes, 4 plus 2 plus 1. So bottom you will have 7. Okay, and CV will ultimately be this is 10 plus 3 13 plus 3 16 by 7R. This is still not done. We have only gotten our CV. We have to find molar specific heat at constant pressure. Now we all know that the constant pressure molar heat specific is equal to CV plus R. So which is 16 by 7R plus R. So we will get aptly 23 by 7R. So the correct answer finally is option D. If you would have marked 16 by 7, that's actually wrong, because they are not asking molar specific heat capacity at constant volume. They are asking molar specific heat capacity at constant pressure. So you need to add an additional factor of R so that you get the final answer as 23 by 7. Once again, not an easy question, definitely, because you need to know the mixture. Okay, so the partial pressure law and how the molar specific heat capacity of a mixture behaves like. So that is very important. So that most of you take it for granted as much as I've seen. So if you have really taken KTG, kinetic theory of gases, very seriously, please go through each and every formula. The question can come from any portion. So please go through the entire KTG and you can mark this question or this chapter as a very important chapter. Okay, very tricky chapter, this and thermodynamics. So please practice as much as possible from these chapters. All right. Yes. In a Carnot engine, efficiency is 40% at a hot reservoir. Temperature it's T. And for efficiency 50%, what would be the temperature of the hot reservoir? So two conditions you have to equate. Okay, once again, look at this. For any Carnot engine, the efficiency is given as eta is equal to 1 minus T2 minus T1, where T1 is the hot reservoir temperature. Alright, so for 40%, when eta is equal to 40%, so you can write the equation as 40 by 100 is equal to 1 minus T2 divided by T. Okay, because T1 is equal to T, right? Hot reservoir is T. Fine. So let's find what is T2. So this gives us that the T2 is approximately, you just have to do it, for 4 by 10 is 2 by 5, and you bring it to this side, 1 minus 2 by 5 is 3 by 5. So it is 3 by 5 T. Okay, so T2 we have got it as 3 by 5 T. So let's assume the final temperature is 3 by 5. Now let us take the next condition, that is what will happen when the eta is 50%. Eta is 50%. So our T2 we already know, it is 3 by 5 T. We have to find our T1. That's the question, right? What's the hot reservoir temperature if efficiency was 50%? So 50 by 100, okay, is equal to 1 minus 3 by 5 into T whole divided by T1. So you have to crack T1. Ultimately, what is the T1 answer? Okay, so the T1 will obviously, if you just calculate this 1 by 2 and there is 3 by 5, 2 cross multiplies, and ultimately you will definitely get 6T by 5 as the answer. Okay, you can work out all the calculation yourself. Okay, if at all there is any contradiction, please let me know then and there itself in the comment section. Okay, so don't forget to do that. Comment section is a very efficient tool so that you can communicate whatever your queries are, your any information that you want to let us know, any additional information. It will be really great. So please do that, students. So the final answer has arrived at 6T by 5. Okay, this again, if you know the Carnot engine concept of efficiency, you can definitely do this. It's this type of problem has been again repeated in a lot of chapters. Okay, they'll give one particular condition and they give a kind of a clue for that. Okay, so if T at 40%, what is at 50%? So you just have to work out at the same formula twice at different levels. Okay, and then you will end up at the correct answer. All right. Yes. Next question. A body of mass 0.01 kg executes simple harmonic motion. The time period of the SHM is. Okay, so first of all, time period formula is somewhere related to K. Okay, so time period formula is given as, time period is given as 2 pi into root m by K. So first of all, we have to find K. How do you find K from this graph? The K is given as the slope. Okay, K is given as the slope, negative K is given as slope. So you can find the slope here. Okay, slope is negative, K is also negative. So ultimately you will have the modulus of K as, see, 80 minus 0 by 0.2 minus 0. So you will get ultimately 80 by 0.2, which is 400. Okay, 400 Newton per meter. Okay, 400 Newton per meter. That's the K. You can get it from the slope. Easily you can find the slope of the graph. So K value is this. Substitute here. M is equal to, already it's given 0.01. Okay. So time period, if you substitute and if you find, ultimately K time period is equal to, hold on, 2 pi root 0.01 whole divided by 400. Okay. So you can take the root directly. Okay, 2 pi, 0.01 root is 0.1, 400 root is 20. Okay, so ultimately you will end up with the answer, see, 0.01, 2 into 0.2 and 1 by 100. So the final answer will be approximately, right, 0.314. Okay, so there is a pi, right? Yes, so there is a pi. So pi into 10 to the power minus 2, which is 0.0314. So the answer is somewhere close to 0.0314. So the most apt answer in the options is option D. Okay, the most apt answer closest to this is 0.03. All right. Yes, so this is how you do it once again. So again, several formulae are very important, are to be known, that is time period and how to find K. Okay, from the given graph, find K and use it in the time period formula. So you will get the answer. So I would definitely place it in easy because these are all something that you're supposed to know, okay, first hand, and just solve it very simply because there isn't any major calculation. You can just directly calculate. Okay, no doubt on that, right? Yes. So very simple question. If you really have practiced this definitely this will prove to be a very simple question. All right, look at the next question. Speed of sound in mercury at a certain temperature is 1450. If the density of the mercury is 13.6 into 10 to the power 3, then the bulk modulus for mercury is, it's a very simple straightforward question. They have given you speed of sound, they have given you density, they're asking you the bulk modulus. What is speed of sound in a particular medium? Speed of sound is given as root over bulk modulus by density. So bulk modulus is absolutely just square both the sides and cross multiply v square into rho. Square both the sides, cross multiply rho. So bulk modulus is v square into rho. So bulk modulus is 1450 whole square into rho is 13.6 into 10 to the power 3. Alright, so it's very simple. So you have velocity formula, from that deduce the bulk modulus formula, okay, and ultimately you will get the answer as, when you just solve this, okay, 14.50 square into 13.6, 10 to the power 3. So it is, yes, calculation is bit on the heavier side. So ultimately you will get the answer as 2.86 into 10 to the power 10. Okay, so it's a pretty large number. Bulk modulus, definitely it's a huge number. So it will come into 2.86 into 10 to the power 10. Fine. Yes, so this is the correct answer. This is a very simple method. Only calculation might be little bit difficult, but even then you can solve it very easily. All right. Yes. Next question. Okay. So two identical conducting spheres carrying different charges attract each other with a force F. Okay. Attract itself means that they are having opposite charges. One is positive, the other is negative. Okay, fine. So let that be anyway. When placed in air medium at a distance d apart, the sphere is brought into contact and then taken again to the original position. Now two spheres repel each other with the same force. Okay, force of those magnitude equal to the initial. Okay, same force equal to the initial force. Ratio between the charges is, see, first of all, you have two spheres, okay, Q1 and Q2. Alright, they are identical, same size. One is positive, the other is negative because there is attraction. Now when you touch two identical conducting spheres, charges will distribute such that when there is any kind of contact, you bring any kind of contact, charges will distribute such that they will attain similar potential, and since they are identical, they both will ultimately end up with a final charge, same final charge. Both of them will ultimately end up with final charge after contact. Okay, after contact, both will have a same charge. Q is equal to Q1 minus Q2 divided by 2, average. Okay, average, but definitely considering the sign. So Q1 minus Q2 by 2. Now what is the condition? Now the condition is that even after you touch both of them, take it to the original place, same distance and all, the force is same, force magnitude is same. So F1 equals F2. So this is F1, okay, initial one, initial F1, and final is F2. Hold on. Yes, F1 and the final is F2. Okay. Yes, final is F2. So now both of them are same. F1 and F2 are same. F1 equals F2. That means that applying the formula K Q1 Q2 divided by R square is equal to K. Now the same charge multiplied 2 times. So Q square, which is nothing but Q1 minus Q2 by 2 the whole square divided by R square. Cancel all the common terms. So you will ultimately have Q1 Q2 is equal to Q1 minus Q2 the whole square divided by 4. Okay, so just cross multiply, open up this bracket, ultimately you will get a quadratic equation which is Q1 square plus Q2 square minus 6 Q1 Q2 equals 0. Yes, ultimately you will end up with this quadratic equation. Okay. Yes, so you have a quadratic equation. Now what I suggest all of you is solve this equation by general method. Okay, solve this quadratic equation and you will ultimately, you can take Q1 by Q2 as Q1 by Q2 ratio, you can segregate to one side. So Q1 by Q2 can be taken as root 3 plus or minus 8. Okay, Q1 by Q2 taken as minus 3 plus or minus root 8. Okay, so you can definitely try this out yourself, Q1 by Q2 formula. Okay, so this is root 3 minus 3 plus or minus root 8. Okay, yes. So the correct answer over here is option C. There is slight correction. This is minus, this is not plus. Okay, so this is plus, this is minus. One of it is plus, it's minus. So it can be both. The ratio can be both. All right, it can be either minus, so minus is common, sorry, minus 3 plus or minus root 8. Okay, yes. So this is the answer. So please take this question very seriously. Why? Because these kind of questions have repeated several times. Okay, these kind of questions have repeated several times. The same question where you have two identical spheres touched with each other. Okay, two identical spheres touched with each other. So what happens here is basically when you touch two identical spheres together, there is a charge redistribution. Okay, and when charge redistribution happens, finally they attain the same potential, and since they are identical, they attain the same charge. That charge is given like this. Okay, that charge is given like this. Okay, so this is how you formulate. Okay, this is how you formulate. So from here you go ahead with the equation of forces. Both the forces are same, you get them and you get the answer. Okay, so please solve them and let me know. So the answer is obviously this one. Okay, minus 3 plus 8 or minus 3 minus 8. Okay, so just calculate this and let me know in the comment section if you have any contradictions regarding this. All right. Yes, look at the next question. What is the SI unit of electric flux? All of you know XI unit of electric flux. So flux is given as electric field into area. Electric field can be written as volt per meter. Area is meter square, so we know it is voltmeter. So the unit of SI unit of electric flux is volt into meter. Very simple. All right. So very simple. Electric field into area is flux. So electric field is volt per meter and area is meter square. You can directly get the answer. All right. Very simple question. Look at the next question. A parallel plate capacitor has capacitance C. When it is half filled with a dielectric of dielectric constant 5, the percentage increase in the capacitance will be. What is the percentage increase in the capacitance? Now see here, initially you had a capacitor, very simple capacitor, epsilon naught A by D. Okay, so you have a capacitor normal with air in between. Now you have a capacitor, it is half filled. Okay, not about distance, we are talking about the area. Okay, so area, half of the area is filled with a dielectric constant K is equal to 5. Now what will happen here? Now it's a parallel connection. Okay, so air acts as a capacitor and this dielectric acts as a capacitor. They both are parallel connection. So the new capacitance is actually addition of both. Okay, this is A by 2. This is also A by 2. So we have epsilon naught A by 2 D plus this one has an additional K value, that is K into epsilon naught A by 2D. So 2D is common, epsilon naught A is common, epsilon naught A by 2D, and this is 5 plus 1, so that is equal to 6. Okay, so ultimately we have C dash equals 6 epsilon naught A by 2D, or we can write it as 3 epsilon naught A by 2D. Okay, so C dash is this, original is this. Okay, so this is the final thing that we have to conclude. Okay, this is the initial, this is the final. Now change. Delta C is equal to C dash minus C. So which is into percentage. You want percentage as well, divided by C into 100. Okay, so this we have C dash is, so there is no 2, already 2 is gone, so we can take off the 2 over here. Okay, so we have 3 epsilon naught A divided by D minus epsilon naught A divided by D whole divided by epsilon naught A divided by D into 100. Epsilon naught A by D is common everywhere, it gets cancelled. 3 minus 1 is 2, so the final answer is 200. Okay, epsilon naught A by D is common, numerator, denominator also common, they get cancelled. 3 minus 1 is 2, 2 into 100, 200. So the correct answer is 200%. So when you have this kind of a scenario where you have half filled with a dielectric of value 5, so you will get a change of 200%. Okay, so delta C by C percentage variation can be found out like this. All right. Yes. So once again, this is not a very simple question. You have to formulate one by one each step, not to falter at any step. If you flounder even in a single step, the entire answer will crash. All right, look at the next question. 3 charges are placed at the vertices of an equilateral triangle of side A as shown in the following figure. The force experienced by a charge placed at the vertex A in the direction normal to BC. Okay, a lot of things to focus over here. First of all, you have 3 charges: positive, negative, positive. Okay, so now what will happen to this particular charge? What will happen to this particular charge at vertex A, and how is it with respect to BC? Force experienced by the charge at vertex A in the direction normal to BC. So you are talking about a force in this direction or this direction, upward or downward. Okay, what happens? First of all, when you take the components, okay, vertical component of this force, so FBA, okay, this is FBA, we are talking about FBA perpendicular, and then we have, sorry, this is downwards, it's a negative charge, so we will have a downward force. Yes, FBA perpendicular, okay, this is the perpendicular, and this is FAC, so they both are actually same. Okay, they both are actually same. Why? Because it's the same charge value, same distance, so they will have same force. Okay, FAC and FBA, magnitude wise they are same. So if the vector's magnitude is same, their perpendicular components will also have the same magnitude. So both the vectors, both the forces are having same magnitude, but in the opposite direction. Same magnitude, opposite direction will absolutely give you the result that they will cancel out each other, and ultimately the correct answer over here is two equal and opposite forces up and down, they will cancel out and you will get the answer 0. Okay, because they have specified in the direction perpendicular to BC. So this is happening only in direction perpendicular to BC. Ultimately there is a force in this direction. Ultimately there is a force in this direction which you can find out. All right, but perpendicular components will cancel out each other. All right, these kind of questions, again, these are all repeated questions. Please make a note of these questions, students. They are very, very important. All right, question number 134. Each corner of a cube of side L has a negative charge minus Q. The electrostatic potential energy of a charge Q at the center of the cube is, first of all, imagine you have a cube. Okay, you have a cube, and at each vertex you have a negative charge. At each vertex you have a negative charge, and now at the center you are keeping a positive charge. Potential energy is given as K Q1 Q2 divided by R. So K Q1 Q2 divided by R, first of all, both the charges are not same. At the center negative, at the vertex, sorry, at the center positive, at the vertex negative. So this both will give a negative product. Okay, positive charge into negative charge, they will give a negative product. So it is not a positive answer, first of all. So option C, B and C can be cancelled. So it's negative. Now among the negative, what is the correct answer? There are 8 vertices. Each vertex, okay, each vertex charge, the charge at each vertex will contribute how much energy? Okay, so U dash is equal to K into minus Q square, okay, whole divided by distance. Okay, now distance from the vertex to the center of the cube. Entire the diagonal of the cube, okay, from vertex to vertex, opposite vertex, it's root 3. So from center to the vertex to the center is half of that, root 3 by 2. Root 3 by 2 into side length is a, okay, sorry, L, so you can keep it as L, root 3 by 2 L. So each vertex will have 2kq, or k you can write it as 1 by 4 pi epsilon naught minus q square divided by 4 pi epsilon naught root 3 L. Okay. Now this you have to multiply with 8 because there are 8 vertices. Each vertices will give this much. So 8 vertices, multiply this with 8. So you will have 2 to cancel. We will have 4 minus 4 q square whole divided by root 3 pi epsilon naught L. So the correct answer here is option D. Okay, correct answer over here is option D. So once again, this is actually very simple because see, you have to do step by step. First, you have to find for each of them what is the potential energy, each combination, like each vertex and the center, what is the potential energy. And then you have to extrapolate to that to 8, all the 8 vertices. Ultimately, you will get the answer as minus 4q square whole divided by root 3 pi epsilon naught L. Alright. Yes, once again, simple question, but if you are not familiar with this, if you don't have enough practice, it is going to be difficult. Okay, so once again, this chapter, please make a note of it. And then the electric potential at a point xy in the xy plane is given by V is equal to minus kxy. Okay, so this is the potential. Now they are asking the magnitude of field intensity at a distance r from the origin varies as. So it is the variation of electric potential, okay, in order to find the field. So now we have to focus on the details of this. That is, how do you find electric field from the variation of potential over a given space? Okay, spatial different variation. So this we already know, it is del V divided by del R. Okay, so we have to perform a mathematical process. I don't know how many of you are aware. So this del V by del R is actually a mathematical function. It applies like this: minus partial differentiation of V with respect to x along the I direction, partial differentiation of V with respect to y along the j direction. So you have to perform a partial differentiation. Okay, so that is how you will get this. And when you do this, when you partially differentiate this V kx ky, so you will get electric field is equal to negative of differentiate V with respect to x minus ky I cap plus you will have differentiate with this with respect to y, you will have minus kx j cap. Okay, so minus, when you bring it in, totally you will get ky, k is common, y I cap plus x j cap. So this is the electric field. Okay, now ultimately the magnitude of the field intensity at a distance r from the origin varies. So electric field in this particular case, it will vary just normally, okay, k into x or y directly proportional. So it directly varies as like this. If you want to find magnitude, okay, how do you find magnitude? So magnitude can be found out by y square plus x square. Okay, so y and x will give the details of the r position. Okay, so this is directly proportional to, magnitude of this is directly proportional to, not r square, because there is a root. Okay, x square plus y square will give r square, but since there is a root, so it is directly proportional to root of r square, which is r. Okay, yes, so this is how it varies. So here in this particular question, the electric field varies with respect to this given potential is r. Option B is the correct answer. Okay, option B. So when the potential is given like this, then the electric field in this particular situation varies with respect to the distance in this particular format. Okay, directly proportional to r. Option B is the correct answer. Now this Yes, I admit it's a very difficult question. It's not easy or mediocre. First of all, you should have an idea of this del function, how the del function applies, and from there how to calculate and assume and arrive at this particular inference. Okay, so I would say that you can kind of see this question for the knowledge purpose to kind of know how the function works, but this kind of question for CET is highly unlikely because it's pretty high level. All right, so anyway, I hope you will gain something out of this question. Fine. Okay, let's look at the next question. So question number 136 is, an electric dipole is kept in a non-uniform electric field it experiences. The same question we have encountered in the previous mock test also. So that's a very simple question. So when we have a non-uniform electric field, it experiences both force and a torque. So the correct answer over here is both force and a torque, option A. Okay, when it's a uniform electric field, it will experience only torque, no force, no linear force. But in non-uniform, it will experience both force and torque. All right, next question. That was very easy question. Next question. Look at here. We have two charges. That is, one is A, the other is B. You can see that the charge is flowing outwards from A and into B. So any charge where it is radially inwards or into a particular charge, that's a negative charge. So this is negative. Okay, so we have this as a negative charge and this as a positive charge. Okay, so A is negative and A is positive, B is negative. But one more thing, that who is stronger, who is weaker, you can see near A there are a lot of field lines, whereas near B there are very less number of field lines, okay, on the side of B. So therefore A is stronger than B, therefore the correct answer over here is option A. A is positive, B is negative. The magnitude of the strength of A is stronger, more than the strength of B. Okay, option A is the correct answer. All right, once again, very simple question. Constantine wire is used for making standard resistance because it has, this is also a very standard question. We all know the answer. It is because negligible temperature coefficient of resistance, because due to the variation of temperature, the resistance will not change much. That's why we use Constantine wires as, for making standard resistance. All right, so according to temperature or situations, the resistance shouldn't vary, it should remain constant. That's why D is the correct answer. Once again, very simple question. Question number 139. Two resistors of 6 ohms and 9 ohms are connected in series to a 120 volt source. The power consumed by 6 ohm resistor is. Whenever you have a power question with multiple resistors, first check whether they are in series or parallel. If they are in series, better you use the power formula as I square R. Okay, it's preferable. In series, I square R is preferable, and when it's parallel, V square by R is preferable. Okay, for series, I square R is preferable. So now what is I? I is equal to 120 voltage divided by resistance. Okay, let me just make it in formula so that you don't have any confusion. Okay, V by R total. Okay, so that is 120 whole divided by our total is 6 plus 9, 15. So this is actually 8. Okay, 8 amperes is the correct answer. So the current here is 8 ampere. Now let's directly go to the power formula. How much is the power formula? Current square into 6. So 64 into 6, it is 384. Option A is the correct answer. Alright, so it is 384 watts. Simple question. So just keep it in mind whenever you have multiple resistance and you have a power question. Check whether the resistors are in series or in parallel. Series, please use I square R. Parallel, use V square by R. Alright, very simple question. Let's look at the next question. Question number 140. A 100 watt bulb working on 200 volt is having a resistance R, and bulb 200 watt bulb working on 100 volt has a resistance S, then R by S is very simple here. Just first write the notations, then we can take it. R is equal to, let it be V square by P. Okay, V square by P, because voltage is given and power is given, so most apt is V square. P is equal to V square by R, cross multiply. So let's name them V1, P1. Okay, this is your V1, this is your P1, this is your P2, and this is your V2. Okay, and S is equal to V2 square by P2. Now take the resistance R by S is equal to V1 square by V2 square into P2 by P1. Substitute all the values. Chalo, V1 square is 10,000 divided by V2 square is sorry, V1 square is not 10,000, 40,000. Okay, 200, right? Yes. So it is 40,200 V1 square 40,000 divided by V2 square. Okay, that is 10,000 into P2. What is P2? 200 divided by P1 is 100. Okay, so just take everything and ultimately you will get 8:1. Yes, so the correct answer is option C, 8. All right, so this is the question, very simple question. All right, so you have 100 volt at 200 volt, 200 watt at 100 volt, two different conditions. So set up the equations right, take the ratio and then just directly substitute, or you can perform the ratio first itself, then take initial ratio first, then take the final ratio, anything. Okay, whatever is convenient. For me personally this is convenient, so just I'll have all the terms at the end and then just cancel out and take the final answer. All right, so very simple question. Once again, look at the next question. Which of the adjoining graph represents ohmic resistance? We all know ohmic resistance. Ohm's law states that at a particular temperature, so the current flowing through a conductor is directly proportional to the potential difference between 2 points. So that basically the best suiting graph to that definition or that statement is A. Okay, directly proportional. All right, directly proportional to current, right? So this is the ohmic resistance display. All right, very simple question. Next question, two wires A and B have same material having the radii 1:2 and current in the ratio 4:1. Okay, the ratio of drift speed of electrons in A and B is, okay, so what is drift speed? First of all, drift speed relation is given as, that is drift velocity is given as I divided by NEA. That means N and E are common. Okay, number of electron density, and E is also the same because we are not two wires of the same material, right? So N and E are common, they're same. That means that drift velocity is directly proportional to current, inversely proportional to area. So also we can bring in terms of area. If we see a circular cross section, it is radius square. So this is the relation. Now we need the ratio. So just use this proportionality to create the ratio. VD1 divided by VD2 is equal to I1 by I2 into R2 square by R1 square. So I1 by I2 we know it is 1 by 2. Okay, sorry, current ratio is 4:1. Okay, current ratio is 4:1 and radii ratio is 1:2. That means when you take the opposite, okay, R2 by R1, it just flips. So you will have 2 square by 1 square. Okay, 1:2. When you flip it, R2 by R1 will become 2:1, 2 square 1. So ultimately you will get 16 in the numerator and 1 in the denominator. So the correct answer is option A, 16:1. All right, once again, the relation of drift velocity and current is very, very important. If you know this, you can then further solve it one by one. All right, once again, very simple question. So this set of question, last several questions have been very, very simple. This is the true nature of the CET examination. Okay, so you can consider these questions as some of the questions which are possible in the next edition. Look at question number 143. When a piece of aluminum wire is of finite length is drawn through a series of dies in to reduce the diameter to half of its original value, the resistance will become. Now first of all, you are making aluminum wires, drawing it into something of half of its original radius without changing the volume. Okay, that is the most important point. Whenever you are casting something, a metal or a resistor, without changing the volume, there is a series of proportionality which I would like to know, which I would like you to know. So the resistance, and in such questions they only give one of the quantities, that is either they give only length or information only about area or radius, diameter. Okay, in this case, so we have directly proportional length square maintaining the volume. So only the length is varying. So resistance is proportional to square of the length, inversely proportional to area square. Okay, area square. And since it's inversely proportional to area square, I can write it's inversely proportional to power fourth power of radius, because area is already r square. Now square that also, it will become 4. And since radius and diameter are proportional to each other, you can write like this. This is a very important relation. Please make a note, students, if you didn't have any idea about this. This is a very important relation. Whenever the volume is kept constant and the question contains only the detail about length or area or any one of them, so you can use this relation very aptly. And here, how do you use it? So diameter decreases to half of it. Actually, your resistance is inversely proportional to fourth power of diameter. Okay, if the diameter becomes half, the new resistance, so it is 1 by d by 2 whole square. So that is proportional to 2 to the power 4, 16 will go up. Yes. So it's actually, sorry, dash comes here, d by 2, there is no dash. So it's actually 16 times the original one. So actually it was d to the power 4. Okay, actually r is proportional to 1 by d to the power 4. So when you want to like decrease the diameter by half, so that means that the resistance will become 16 times the original one. So the correct answer is option D, 16. Okay, once again, this relation is extremely important. Please make a note. These kind of questions are asked a lot. Okay, so please mark this question as well, where the volume is maintained constant without variation in the volume. How do you kind of decrease length or increase length, decrease area, radii, diameter, all that? Okay, once again, this is a very simple question. If you know the relation, you can do that. Next question: charge particle of mass m and charge q travels circular path. The time taken. They are asking the time period. The time period formula is pretty straightforward. Time period of charge particle entering perpendicularly into a magnetic field, and it goes through a circular path. So time taken for completing one revolution, time period of a charge particle taking a circular path when entering the magnetic field perpendicularly is 2 pi m divided by qb. Okay, so this formula is very kind of, it's given. So most of you, we study it when we study about the circular path motion of a charge particle in a magnetic field when it enters perpendicularly. So all these are kind of generic formulas that we already studied, very direct. We can deduce it, but that's not our point. Okay, so deducing is not our goal. So directly, this is the answer. You can take it down. There's a very important expression as well. Next question: a charge moving with a velocity v in the x direction, okay, it is subjected to a magnetic field in the negative x direction. What is the force? We all know, if the magnetic field direction and the velocity direction of the charge, if they are either parallel or anti-parallel, then the charge doesn't experience any force. Why? Because the magnetic force is proportional to v cross b, or Vb sine theta. So suppose if the theta value is 0 or 180, okay, 0 means they are parallel, 180 means they are anti-parallel. So then the sine factor will cancel out the entire term. Okay, sine 0 or sine 180 will make it 0. The entire factor becomes 0. So actually it will remain unaffected. The force experienced is 0. Magnetic force will be 0. Okay, if theta is equal to 180 degree, okay, because it is going in, particle is going in the x direction, magnetic field is in the negative x direction, the angle is 180 degree, therefore no force, it will remain unaffected. All right, look at the next question. A galvanometer having a coil resistance of 100 ohms gives a full scale deflection when a current of 1 milliampere is passed through it. The value of resistance which can convert this galvanometer into ammeter giving a full scale deflection of current of 10 ampere is. So basically it's a question of conversion of galvanometer into an ammeter, and that's directly asking the shunt resistance. The shunt resistance formula for ammeter conversion is simply galvanometer current into galvanometer resistance, the ammeter, converted ammeter current minus galvanometer current. So it is 10 to the power minus 3 into 100 divided by 10 minus 10 to the power minus 3. Okay, so this is approximately 0.01. Okay, it's very simple. So it is approximately 0.01 ampere. All right, so this is the correct answer. Very simple. So this direct formula for ammeter, as well as there is a formula for conversion of voltmeter as well. So these two formulas, please keep it in mind in case of conversion of galvanometer. So moving coil galvanometer is very important. So first the sensitivities are very important. Later the conversion. Okay, conversion factors and formulas are very important. You will directly get the answer as 0.01 approximately. All right, very simple question. Once again, very straightforward indeed. At what distance from a long straight wire, okay, carrying a current 12 ampere will the magnetic field be equal to? The long straight wire magnetic field at a distance B is given as magnetic field at a distance from the long straight wire is given as 2 pi r. So r is simply mu naught I divided by 2 pi b. Mu naught by 2 pi is 2 into 10 to the power minus 7. I is given as a 12 ampere and magnetic field is given as 3 into 10 to the power minus 5. So 3 and this, so ultimately you will get 8 into 10 to the power minus 2. Simple. Okay. 8 into 10 to the power minus 2 is the correct answer. Alright, so there is no question of doubt or any kind of contradiction required in this particular question because it's very straightforward. Okay, there is nothing to be confused over here. Magnetic field from a wire at a particular distance. That distance, just rearrange and you can find the distance. Alright, very simple question. Look at the next question. Alright, so current I is flowing in a coil of area A and the number of turns is N. And then the magnetic moment is equal to, they are asking you the direct formula for magnetic moment. Magnetic moment is equal to number of turns into I into area. Simple, NIA. Alright. Yes, option A is the correct answer. Once again, very simple, very straightforward question. Okay, directly you can write it. So this question of question 149, a coil in the shape of equilateral triangle of side 0.2 meter is suspended from the vertex such that it is hanging in the vertical plane between the pole pieces and the permanent magnet between the horizontal magnetic field of 5 and 10 to the power minus 2. The couple acting on the coil when the current of 0.1 ampere is passed through the magnetic field is parallel to the plane will be. So first of all, the formula is very clear. So they are asking you the torque. So torque formula is NIAB and area. So how do you find area of an equilateral triangle? It is found by root 3 by 4 into a square, where a square, a is the side length. What is side length? It is 0.2 this, so it is 3.4 into 0.2 the whole square. This is the area. Now substitute in the torque formula, that is N is equal to 1, okay, and current is given as 0.1, all right, 0.1 into magnet area is root 3 by 4 into 0.2 whole square into the last thing is the magnetic field 5 into 10 to the power minus 2. So when you multiply all of this, okay, you can calculate, you can just check it yourself, multiply all of this, common terms will cancel, 0.2 square 4, some factor will get cancelled, and ultimately you will get the answer as 8.66 into 10 to the power minus 7 Newton meter. The correct answer is option C. Okay, the final answer is 0.66 into 10 to the power minus 7. So you can check the calculation yourself. If at all there is any contradiction, please let me know, students. Alright, so very simple question. Fine. This was the penultimate question. Let's see the final question of this part. So the final question is magnetic field intensity is defined as, the magnetic field intensity is actually defined as the magnetic flux density, that is number of field lines crossing per unit area, number of field lines crossing per unit area. So in a given area, how many field lines passes? More the field lines, more is the strength of the magnetic field, more is the intensity, less is the number of field lines, less is the strength, less is the magnetic field density. Very simple question. Magnetic field intensity is the number of lines of force crossing per unit area. Alright, so that is the end of this particular session of all the 30 questions, part 1. All of you who have liked our video, so please don't forget to press the like button and also there are so many people who are in dire need of this video. So please share this video with all of them so that all of them will be benefited with this, and also to create more and more such genuine content for all of you. Please don't forget to subscribe to our channel Diksha Karnataka, and for timely updates press the bell icon. All right, so until the next time with another video, this is me Karthik signing off. Adios.